Alright, so today we're going to be looking at geometric progressions and their sum to infinity. Now, what is a geometric progression? For the sake of this video, we're going to just be shortening it to GP. A geometric progression is a series such that you have your first term A, and then you have your first term times the common ratio R, and then your second term, which is going to be the third term, which is just going to be the second term times R again. And then this goes on and on. This is different to a regular arithmetic progression, which we'll call AP, where you have your first term and then you have your common difference D, where it's going to be A plus D, A plus D plus D, which is going to be A plus 2D, and A plus D plus D plus D, and so on. So let's now look at the sum to infinity. The sum to infinity is a formula that allows us to actually find out what all of these terms here equal to when added up. And the formula for this is A divided by 1 minus R. However, note that for the sum of infinity to be valid, our value of R, the common ratio, has to be smaller than 1, yet larger than -1. So let's now demonstrate this with an example. Let's take this geometric progression, which is going to be 1 over 2, 1 over 4, 1 over 8, and so on. We can identify our first term here, A. However, now we need to find R. But we know that R is the n plus 1th term divided by the nth term, which will take the first two terms for this. We'll do 1 over 4 divided by 1 over 2, which just equals to 1 over 2. So now that we have our A and our R, we can actually calculate the sum to infinity, which is now going to be 1 over 2 divided by 1 minus 1 over 2, which is our R, and this is our A. So now that we have 1 over 2 divided by 1 minus 1 over 2, this just equals to 1 over 2 divided by 1 over 2, and any number divided by itself equals to 1 over 1. Therefore, we can state that our sum to infinity here is 1. While this may sound hard to believe, we can also represent this geometrically. Let's take, for example, this square. Sides of length 1. Now, the total area of this square is going to be 1. However, if we were to cut this square in half, I would have 1 over 2 here and 1 over 2 here. But instead of labeling that as well as 1 over 2, let's cut that in half as well. Let's get 1 over 4. And the square below it, cut that in half, 1 over 8. This just goes on and on and on. 1 over 16, 1 over 32, and this never ends. However, if you'd notice, this is our exact geometric progression from before. And so when we add up the areas of each of these squares here, we end up with the area of the large square, which is 1, which is also our sum to infinity.